Hey there, classes, welcome. And if you check it out, this is the YouTube portion of the class where you can go over some of the things that we've seen in class. I will try and be breaking up science versus math as the year goes on. This one is less about content, it's a little bit about more what to expect, what you'll see in this class, what you'll need to keep track of in your notebook. And so let's jump on in. I always try and make sure, both in class and for these YouTubes, that I keep it to 10 minutes or less. So I'll flip this over just to remind me. And if you look at the picture that's on the board before I turn off the screen, this from science class was from a Stephen Hawking video. Now, Stephen Hawking made a series of videos taking average people and guiding them through the scientific method, the scientific process to discover something about the universe. In this case, he was talking about the size and the scale of the universe. Now, in science class and in math class, we start with measuring units, the metric system. And so let me turn this off. You'll notice that they're talking in this particular case about a sphere. And when we are talking about some of the formulas in class, in science, we started talking about the volume of a regular prism. We did the area of the classroom, we did the length across, the length, the width, and then finally the area of the classroom in terms of volume. And that is going to lead us into our very first scientific exploration into the entire size of the universe. In other words, when students come on in tomorrow, we're going to guide them through a little bit more about scientific notation and the way that we can use that to express the large numbers that we need in both science and in math class. On the Mondays or whatever the beginning day of that week is, but usually a Monday, in science class we often do the key terms, which are the terms that we'll be referring back to throughout the rest of that week. And then going forward, students will keep an ongoing notebook and they'll see some of the same terms pop up again and again. When the students came into class day in science, they saw a brain pop, a little bit about the Big Bang. And when you look at the Big Bang, like Big Bang Theory, like the TV show, it's one of those things like, well, how do we know? How do we know that the universe is about 14 billion years old? And we go into a little bit about the observations that help us make that inference and a little bit about the data. In terms of the crossover with the math classes, this is why I love teaching both science and math in the same school year. When we are doing the Cartesian coordinate system, which was one of our key terms in science this week, we're talking about graphing. Now, a lot of what we do in the math class has to do this year with graphing, XY coordinate system. And in terms of the brain pop, and I'll go into this more in detail on the notes, which will be posted at pacificascience.org. We're talking about the X, the Y, and the coordinate system, where in science we'll generally be talking about the first quadrant here. So we've got, of course, I'm writing it quickly, so it's a little messy here, but our 4 quadrants in the Cartesian coordinate system. We'll be doing quite a bit of work up here in the first quadrant, where we're gathering data, we're looking at our independent variable, we're looking at our dependent variable, and we're going to talk just a little bit about how Hubble and other scientists started plotting the distance to galaxies, and they started plotting the speed with which those galaxies are moving away from us, and using that inference. We were looking back in time saying, based on this observation and this data, we can roughly tell you how old our entire universe is. I personally find that stunningly amazing that you can take the simple data, you can put it in a graph and run it backward. I use the example of my daughter. My daughter went to a Taylor Swift concert of all things a while back. I didn't get a ticket. I was outside having dinner at a local restaurant while her and her friends were at the concert. If you can imagine a lot of people, say 40,000 people or whatever it was, gathering at Levi Stadium for this concert, you've got them all gathering together, watching the concert, and then leaving after the last song. If you can imagine you're a reporter, you're filming it from a helicopter or with a drone, you would see all the people scattering away from that one place where they gathered, going back to Millbrae or San Jose or San Francisco or wherever they came from. And the point is, if you were to run that movie backward as they left the concert, you would roughly see that they all gathered at the same place together at one point in time. It's a little bit, not the best analogy, but it's a little bit like how we know that the universe expanded from a single point, most likely, in the neighborhood of 14 billion years ago, we're basically running the movie backward. We're saying, okay, if the galaxies are moving at this speed and they're this distance apart, how close were they, say, 5 billion years ago, say 10 billion years ago? We can run the movie backward and see what it looked like. Going over into math class, so there's 2 periods of math taught in here during the day and 3 periods of science. Going into math class, you can see we're using a formula here. In this case, in math, we're starting off with the area of a triangle. We talked a little bit. You reach over here and grab a pendulum that I used in science class for one of our first experiments. But we're talking about when you're calculating the height of a triangle, you're going to have to drop basically a plumb line, which is an elevation of the triangle when you have the base in such a way that it's not directly over the high point, if you will, the vertex in that triangle. And so we're getting a little bit of practice today on working with formula. We're going with our very first formula of the year, which has to do with triangles and the area, base, and height. One last little thing before the students were given their practice. Now in math class, generally, they'll be given an introductory question. We'll go over the previous night's homework. We'll do some direct instruction on working on a new skill for that particular day or week. And then the students will be given some practice that they will start in class, and then that extends into their homework. In this case right here, they're given a little bit of practice with, pull it up right here, calculating the area of some triangles. So this is due tomorrow. And when they calculate the area of the triangles and we bring it back to class tomorrow, we go through some of them. You're going to see a lot of classes show the formulas in different ways. All of these different ways of showing it are fine, but one of the things that I try and express quite a bit because of my crossover with the science is writing it out using rational numbers and separating them by parentheses. The why of this is later on, when we get into things like speed, distance, time, density, mass, volume, different formulas in science class, writing things out with this format really helps when it comes to cross-canceling units. And cross-canceling units is absolutely critical both in physics and in chemistry, not just this year or in 8th grade, but going forward into your high school and your college careers. That's where I'm going to leave it today, but look for the notes online at pacificascience.org. And I just wanted to give you a feel for what's on the board. Students are asked to write down what is on the board both in science class, and if they happen to have me for math as well, both in science and math class, in a science notebook and in a math notebook. And then again, most of the time, the students can then use that either on the test, if it's an open note test, or use it to study for the test if it's a closed note test. See you here throughout the year. Have yourself a wonderful Wednesday. Take care, everybody.